Welcome to the video. We, Swarm Mechanical, students of Muthoot Institute of Technology and Science, are going to discuss about the power clamping, its needs, and major types of power-assisted clamps used in detail on the subject manufacturing process. Using power clamping, a number of clamps of various types can be operated simultaneously. Power clamping can be implemented using the following means: hydraulic and pneumatic clamping, vacuum clamping, magnetic clamping, electrostatic clamping. Many of the types of clamps explained earlier can be operated using a few of the power clamping methods. Some power clamping methods are employed for specific applications involving special clamps or even without any clamps at all.
So welcome to the lecture on hydraulic and pneumatic clamping method. This is actually a type of power clamping method. We know that the clamp is used to hold workpieces. So in our day-to-day life we are familiar with some clamps which are manually operated, but for great industrial purposes we use power clamping method to hold heavier workpieces. Actually, power clamping is a power-driven work to hold devices which is very controllable, which is very reliable, and which will also reduce the effort of the operator. It is actually more faster and more efficient, at the same time controllable than mechanical clamping method. So here we are going to discuss about hydraulic and pneumatic power climbing method. As the name suggests, here we use fluid pressure to hold or to give grip to the work pieces. So let us move on to the working principle of this power climbing. So let us look into the figure. Here we can see that a piston cylinder arrangement is used to uh, for clamping. So we can see that when we are looking into the figure, this piston cylinder arrangement is connected to the lever, and this lever is connected to the clamp which is used to hold the workpiece. So this is actually a schematic diagram of a power clamping method. The piston cylinder is attached to clamp by using levers. So when we apply pressure on this piston, what happens? Let us see. When the piston, we can see that there is a passage for fluid to enter. So as the fluid enter into the cylinder, the force exerted or the pressure exerted by the fluid increases. As a result, the piston moves forward and backward. That means the piston reciprocates. As the piston moves forward, the clamp is connected to the work device and it hold it in its place. But when the piston moves backward, what happens? We can see that the power clamp will unload itself. The lever will release the clamping pressure on the workpiece and we can unload the workpiece. This is actually the working principle of hydraulic and pneumatic. Actually, both of these have are working under the same principle, but there are few differences between hydraulic and pneumatic power clamping. In hydraulic power clamping, we use pressurized oil. So as in the slide we can see that a pressurized oil which is almost zero point 0.7 to 25 megapascal pressure is used in hydraulic power climbing, and in pneumatic power climbing we used compressed air which has less pressure, which is almost zero point 0.3 to zero point 0.6 megapascal. As we know that the compressed air has less pressure compared to the oil, we need large cylinder we need large cylinder piston arrangement for compressed air. That means for pneumatic uh, power climbing. But for hydraulic power climbing, we can produce high pressure even though we use smaller cylinders. So this is actually the working principle of pneumatic and hydraulic power climbing method. So let us discuss about the regulation of this clamping method. So we need to regulate the clamping pressure on the workpiece. So for that we use valves. So valves are used to control the pressure, the clamping pressure, um, which is given by the clamps. So we all know that as the force exerted by the fluid decreases, the climbing pressure also decreases. But as the fluid flow increases, the climbing pressure also increases. So by regulating the valves, we can regulate the climbing force also. Also, we can change the direction by using valves. So the valves are employed on both sides. So in this figure, we can only see one passage, but there there may be two passage in the real arrangement. So this is just a schematic diagram. So there two valves are employed so that the piston can be controlled in such a way that it can be moved forward and backward. We all know that as the piston moves forward, the clamping happens, but as the piston moves backward and the clamping is unclamping happens. That means the piston, the workpiece can be removed from its position. So uh, this is uh, regarding the working principle. So there are also clamps. We can actually use a number of clamps in a single hydraulic system. So that means uh, here in this diagram we only see one clamping arrangement. In reality, in great manufacturing process, we can use lot of clamps in one hydraulic system, and the force exerted by them will be equal. And uh, also high pressure is used for heavy cuts, and low pressure can be used for finishing operation. This can be controlled actually. The pressure can be controlled actually using valves, and the risk of sudden pressure drop can be eliminated by providing non-return valves along the hydraulic circuit. That means we are using non-return valves to to avoid the risk of sudden pressure drop. So this is what I could say regarding the working principle of hydraulic and pneumatic power climbing method. And there also we employ hydraulic booster. That's a special term. This hydraulic booster is used to convert lower pneumatic pressure into higher hydraulic pressure to operate in hydraulic powered clamping system. So next we can discuss about some advantages and disadvantages. So I told you earlier about the uh, mechanical power climbing. So actually this power climbing method was used or invented to overcome these limitations. So let's see what are the limitations in mechanical climbing. So in mechanical climbing we can only use we only get limited clamping pressure. Also, the clamping force is variable, so the clamping force between the two components varies with the time. So also the more time consumption, the time used for this clamping will be more high, and operator fatigue, and the operator will get greatly tired because he it is a strenuous effort to clamp components. So in order to overcome these limitations, power clamping like hydraulic and pneumatic clamping method was invented. So what are the advantages? It is faster, then it is uniform and equalized clamping pressure. The clamping pressure is uniform throughout and it is equal and less operator fatigue. So it is very easy to operate, and that's all. And I hope all of you have understood this lecture, and thank you.
Good afternoon, all. I am here to take a class about vacuum clamping. What we can tell about vacuum clamping. Vacuum clamping plate is clamp is used to clamp as like a machine. Exactly, clamping plate is clamped on the clamping station by means of pull studs, and the workpiece is clamped on the clamping plate by means of a vacuum. The compressed air on the vacuum clamping plate is sufficient for secure clamping by means of negative pressure. Working of vacuum clamping. A vacuum clamp holds a work piece to a stable surface using atmospheric pressure. The clamp has a seal that forms air chambers between the clamp and the workpiece. The vacuum pump removes air from the chambers, which reduces the atmospheric pressure in the space between the clamp and the workpiece. What are the advantages of power clamping? Ability to hold non-ferrous materials easily. Faster clamping of material. Reduced cycle time via efficient cutting. Also, higher accuracy is available for power clamping. More parts can be clamped per hour. Also, a decreased material waste. That are the advantages that for power clamping. What are the disadvantages of vacuum clamping? A main disadvantages to vacuum clamping is that there is a limit to how many parts can be clamped at once. There will always be small vacuum leaks due to variations in flatness on the clamping surfaces. And additional parts increases the opportunity for leakage. Too much leakage can cause insufficient clamping. This is the main disadvantages of vacuum clamping. Features of vacuum clamping. What are the features of vacuum clamping? High horizontal holding forces, up to 30% increase compared to vacuum plates without friction parts. About 30% of increase can be done by vacuum plates, using vacuum plates without friction pads. So it is more accurate than the other holding forces. Also, no additional force of the friction parts on the workpiece. Any of the additional force is on the friction parts. And also, oil and ozone resistant are individually replaceable in case of wear. In case of wear, we can individually replace by resist oil and ozone. Activation and deactivation automatically via vacuum supply. I am concluding my words by saying that vacuum clamping is necessary for clamping. Thank you.
Today we're going to see a type of clamping process known as magnetic clamping. Before moving on to the topic, let us go through a summary of what we're going to discuss today. The summary includes the introduction part. Here we will see what is magnetic clamping, and next we will see the process of magnetic clamping, and last we will see the advantages and disadvantages of magnetic clamping. So let us go through the introduction part. As we all know, the process of clamping is that it is the pressing of a workpiece or a material against a surface to hold it in position. This process is known as clamping, and the tools used for that process is known as clamps. In magnetic clamping, magnets are used to clamp the workpiece in position. For this purpose, permanent or electromagnet can be used. So let us move on to the process involved in magnetic clamping. Here we will see the process involved in magnetic clamping under a permanent magnet. As I said earlier, for this purpose, electromagnet or permanent magnet can be used. Here we will see the working under a permanent magnet. So the permanent magnets are mounted on a sliding member and it is moved under a non-magnetic material. Here the non-magnetic material is used because to block the influence of the magnetic flux, and clamp is operated by a lever. As we all know that basically a workpiece is kept on the surface of the clamp, and under the surface there are a number of permanent magnets. So in on position of the lever, the permanent magnets slide into the position. So in on position, the magnetic flux passes through the workpiece and clamp the workpiece to the surface. And in off position of the lever, the flux passes only through the clamp surface only, not to the workpiece. So it unclamps the workpiece. So this is done due to the help of the alternative strips of magnetic and non-magnetic materials. We can see with this help of a diagram. Here we can see that the workpiece is clamped onto the surface, and under the surface there are alternative strips of magnetic and non-magnetic strips. So the purpose of the non-magnetic strips here are act as a flux dumps. So when the lever is turned on, the non-magnetic strips blocks a part of a magnetic flux so that the workpiece is clamped onto the surface. And when it is in off position, the magnetic strips blocks the magnetic flux so the workpiece is unclamped. This is the purpose of the non-magnetic strips included, and here we can see an application of magnetic clamping. Here we will see the lever used for operating the clamp, and here we can see an application of magnetic clamping. Here a workpiece is clamped onto the surface and a machining process can be done on it. And so we will move on to the next process. Here we can see the working of a magnetic clamping and electromagnets. So in magnets working, electromagnetic table uses solenoidal coils. So when current passes through these solenoidal coils, it acts as a temporary magnet. So we can say that when current is turned on, it magnetizes the table, and when current is turned off, it demagnetizes. So when current is passed through it, the workpiece is clamped onto the surface, and when the current is turned off, it unclamps. So the workpiece is released. So this is the basically the working of magnetic clamping under electromagnets. So let us move on to the advantages offered by magnetic clamping as compared to other processes. The first advantage is the speed. So in magnetic clamping, we do not have many steps for clamping. So here the process involved is very less. So if we can quickly set up the workpiece and clamp it, which leads to the no waste of time. And next is the flexibility. Flexibility includes that any magnetic material of any size or shape can be used for clamping under magnetic clamping, and there is no clamps involved. So as there is no unnecessary parts, so there is no need for positioning, again positioning of the workpiece for any machining purposes. Next is clamp consistency. Here the magnetic clamping offers predictable and reliable clamping. So we can say that in any process we have to ensure that the workpiece is kept in position and it is held together so it is not moved and when a machining process is underway. So magnetic clamping offers clamp consistency, that it ensures that the workpiece stays in position Next is the low maintenance. As we can see, the basic component of magnetic clamping is of course magnet. So there is no little maintenance of a magnet as compared to other process. So there is low maintenance. And next is energy efficient. As we saw in the case of an electromagnet, there is a need for an electric current to pass through to activate the clamping and declamping process. So in this electrical consumption, there is only required a few seconds of electrical consumption only. So there is no waste of energy. So these are the advantages offered by magnetic clamping. So that's all. Thank you.